Oh, let's see here. Alright, guys. Trying to figure out how I can explain this. Let's talk about, well, getting more power out of your chainsaw. Typically, ways to get more power out of your chainsaw. Typically, I don't know if I got one here again. See how that transfer is? It's got that big step. The charger's got to come up and then do a swoop in. You can come in here and grind out your transfer and flow it right into the case. You want a nice transition from your crankcase into the transfer. So it's just a nice straight shot up. That will make this is an air displacement pump is how you have to look at it. That will make this air displacement pump more efficient in that regard. You got intake timing. And when we're talking about intake timing, we're talking about this lower part of the port. If I am worried about total degrees of opening, it's this port right here. And the only time I worry about total degrees of opening is by chance, say this comes down and hits here at, and I'll use some numbers that I actually use. I know some guys that do this don't want to give out their numbers. I don't care. I share everything with you guys. It don't matter to me. I'm not really in it for the money. So right here, typically 80 is a really good number. When this comes down and shuts off, I'll look at the degree wheel and that'll be 80. Then swing it back around, and if it comes back up and cracks at 80, you just add the two together, and that's your total opening. If it's different, then I'll actually use that degree wheel I got from Joe that's digital, and what I'll do is I'll set this right to where it cracks, zero that wheel out. And you can do it with a normal wheel too. You don't have to have the digital one, but I'll tell you right now that digital one, being able to push it on the fly and get a total degree opening is really handy. But I'll zero it out, then I'll roll it all the way around till it comes, well, went too far there, till it comes back and shuts off. And then I'll look at the wheel and it'll tell me the degrees there. Sometimes where they place these at and the rod ratio is, changing your piston speed as this swings around. But say if this was 65 degrees and you bumped it up, 80, you'd see a big gain. Typically, if it's a small teeny weeny carburetor, I will push them sometimes a little farther because it allows more time for the fuel to flow through a smaller hole through the carburetor to fill the crankcase. But on a big carburetor, sometimes you got to work your way up. If you go too much on this port or too big on your intake port, you will kill your velocity and your throttle response will suffer. They'll be real sluggish. And then steels are really bad for spit back to begin with. If this was at 65 and there's room to get it to 80, it's nice to come in here and be able to, take this section out, because the more, if it comes in and has to hit and then go this way, you're slowing it down. It would be nice to be able to just, come in and have it, go in there a little easier. But between 78 and 80 are pretty, what I consider safe numbers to go with, that they typically won't get you in trouble. So that would give you more power. Adding compression, changing your, say if this was at top dead center and it was like an Echo and your squish band looked like that at top dead center. Yes, believe it or not, a lot of Echoes look like that at top dead center. Not sure why. But tightening up your squish, that'll get you more power. Coming in here and welding up, like you hear me talk about, I welded up the chamber like I did on that 660. That's where I turned the jug upside down and I snuck my TIG torch in there and I filled in this area right here with weld and then reshaped it, and then had to retap my spark plug hole. But I effectively made this smaller, which increased the compression. But your squish band is right here, and on most cases between 20 and 25 is what I like. If it's a bigger saw, I'll stretch it a little more. The bigger your slug is, the more expansion rate it needs. If it's a work saw, I typically like 25. Just leave room for the carbon buildup. Otherwise, the carbon will build up and eventually it could run into a problem. But I never worry about carbon buildup. I run red armor. That stuff really cuts down on carbon buildup. It'll actually, if you got carbon buildup, that stuff will actually start eating carbon off your piston and chamber as well. There's plenty of videos out there proving that. It's good stuff. I like it. And I tear saws down all the time that I run all the time with that stuff, and I've seen no ill effects so far of running red armor. But yep, if you tighten up your squish band, that'll get you more power. Sometimes we raise the roof, but if you raise the roof and don't raise the compression, you could actually lose power, make a real peaky saw. Good roof numbers for me, I would say I run a lot at 102. Like for most of my work saw builds, where this cracks at's 102, but 100's good. On little saws, I typically don't go much past. I mean, I've got some 4910s out there that are 100, and I got a lot of them out there that are 102s. Let's see. Got a couple out there that are on 98. The reed saw, that's at 96. But I did a lot of work to that. I did chamber work. I, cut the base a lot. I, matched the piston to the chamber work. There's a lot of different ways you can gain power. You could come in here and open up your windows. When these come down, they help feed. I don't know if I got a flashlight or not, but they help feed air from up through here and into your transfer. Because sometimes those lobes of the crank get in the way. Trying to think. But yeah, anytime you add adding compression, and there's people out there that say they don't like to add compression or whatever. That's not me. I love compression. I was raised on it. To me, when you add compression, I feel you get power at every increment into the saw across the board. There's some that say like at super duper mega high RPM, it might cost you a little. I don't typically build super high mega RPM saws, so that's probably why I don't. It doesn't bother me. I mean, there is added stresses to your needle cage, your rod, your bearing here, your crank bearings, but I typically don't see a problem. I mean, I suppose if you went like skyrocketing crazy high on the compression, it could seriously hinder it, but bumping it up 30-40 pounds, I think it's a great thing to me. But that's just me. I'm not going to argue with someone else's ideas. Let's talk about other ways to get more power. You can go bigger carburetor, it gets more air in. But when you start going down that road, you really got to pay attention to your timing. Because if this gets filled up before that You want to find that close relationship where this is filled and this is almost shut, because this needs to shut. Because if this is, say if that's filled right there, the distance from here to there, you just killed all points of velocity and everything, your flow and everything, because it just spit it all back out the carburetor. That's where reeds are nice, because reeds, like a little check valve, it comes back and shuts it off, so it's everything, it forces everything up the transfers on reeds. So let's talk about how else we can add power. Well, how can you add compression? Well, you can come in here, providing there's room. And when I talk about free port, that's the distance from the bottom of the skirt to the bottom of the exhaust port. If there's room, you can come in here and machine this out. Say I wanted to get, say if this was at 98 or something on the exhaust, and I wanted to turn this into a long bar pulling, grunting, firewood eating machine, I could come in here and cut the chamber. This allows me, and you can typically cut the chamber as far as until you run, because when you cut that chamber, this part of the new part of the cylinder wall that you just created right here will not have no plating on it. So you have to be mindful you have till that ring goes up there, because you definitely don't want your ring going above your no plating, but you have the top of your piston to the top of that ring to play with, as long as you don't free port here. So say if there's 40 thousandths that we could play here and still have some left over where it's not free porting, we can cut 40 thousandths out of here, and then we can cut 40 thousandths off the base, and we can drop this, and that will then move this exhaust port down. At the same time, it's moving your intake timing, and then at the same time, it's also bringing this down. So your blowdown, if you've not ground on this port, your blowdown will have not changed at all. The blowdown is from the distance top of here to when this cracks. The only two that we've changed is where these open and close at. That's the only thing. So now we effectively, when you hear me say I lowered my exhaust roof, that's what I did. Is I went in, cut the chamber in the base, and I brought this down to a number that I wanted. And so we just gave this more time from point A to point B to get more power exerted out of the chamber burn, so that in fact we got a gain there. And then on top of it, we made this area smaller, so we just added compression. We got another gain there. Side note, we just gave it more intake timing, so we got a gain there. And if I lowered it, sometimes I'll cut so much out, I'll actually have to go in and raise this up a little bit, but still be lower than what it was before. Say if I cut say this was at 98 and I wanted 102, but after I was done doing all the machine work and this thing landed at 110, I could come in here and raise this back up to 102, and then I'm changing my blowdown. I'm gaining more blowdown, which to me, blowdown, the more blowdown I feel is better. I like long blowdown saws. I've said it right from the get-go. There's other builders that don't. That's fine. Build your guys' saws the way you want to build them. I'll build mine the way I want to build them. But more blowdown is less chance of reversion. Reversion is where, when this starts coming in, if exhaust gas pressure is not below what this is, it will actually push, like I'm sure you guys have torn your saws apart, and this will just be all loaded with carbon in here, and that's from reversion. And if you're pushing exhaust gases, spent exhaust gases, back down your transfers instead of getting them out, you're diluting your fresh fuel charge, and you're hurting your power tremendously. It's unreal. So I hear other people say they like they like these higher with less blowdown because you got to start the fuel getting in sooner at higher RPM. Well, on a peaky race saw or something, that might be the case, but on my firewood cutting machine, that's not what I want. You know, if you raise this, you have less pressure by the time, you know, I want this to be almost all the way pressurized as much as it can by the time my transfers crack open. That way my charge is coming in at a higher rate of charge, you know, higher rate of speed, and keeping all my air fuel suspended in there. So let's talk about some other things. Well, how can I get more power? Well, you can lighten your piston. The lighter this piston is, the easier it is to throw up. And for if this is lighter, as this is expanding and pushing down on it, it takes less energy to push it down. So you're gaining, anytime you can lighten a piston, I call that free horsepower. So if you lighten a piston, you're gaining free horsepower. Let's talk another way. Tapering your piston. If you take your piston, I know some builders are going to get mad about this, but whatever. If you come in here and cut this, instead of this being a straight 90, you come in here and come in so far, you know, let's scribe a line here and say that far, and you cut this on a taper. You know, you don't have to go all the way around, but if you're doing chamber work, it's easier. You cut this on a taper, you know, all the way around. You just gained flow. And by what do I mean by that is, instead of being a straight 90, when this transfer port cracks open, it's tapered now. You just added space between here and there. You're gaining flow. A tapered piston can really increase flow. But if you don't want to do the whole piston, you can come in and mark your piston where your transfers is and just taper just the area, and you want to bring it back so it, you know, still follows, that you can taper just the sides where your transfers are. If you taper that, I don't have a good way. I wish I had another junk piston I could taper it and show you guys, but if it's tapered, it's going to flow more. And then tapering it, you just effectively took that from a, especially if you know, like some people leave a button or a pop-up. Grab a pop-up here and show you. Here's a pop-up. This is what we call a pop-up. This is what we call a flat top. If you do, you know, there's that lip. If this was cut on a taper instead of this flat spot, this piston would have made more power. Sometimes these pop-ups can actually hinder flow because it comes out of the transfers and hits this pop-up and then gets all cattywampus in there. But typically if I cut a piston on a taper, I will cut that same taper into the chamber. That way up here, the piston's fitting up in, and that taper is matching top and bottom, so I can still keep my even squish band. Otherwise, if you don't machine, you know, your combustion chamber to the taper, then you're going to have a weird, your squish will be wider here and narrower here. I typically like to machine the you know, if you spend all the time you do the machine work, you machine the squish band and the piston tapered. That will give you more power, more flow. What happens when you, let's see here, I wanted to show you guys what I call a dome piston. See, this is a dome piston. This is a radius. It's, you know, part of a radius. You got pop-up. You got what I call a dome. Well, which is better? Well, I feel a dome is. A dome will get more power than a flat top. Well, why is that? Let's take this piece of wire right here. And look, that's the same distance from one end to the other. So that's the diameter of that piston. All right. Let's take another wire and let's give it a dome shape. Try to fit it in here. Still not there yet. This is a little bit exaggerated, but I don't think you'll get one almost there. Alright, there we go. I've got to imagine that being the top of the piston. Dome shaped. Alright. Well, why is a dome going to make more power? There's more surface area. Well, what do you mean surface area? Surface area is when your rapid burn is happening, it's putting pressure all avenues in every direction. You know, that dome's all the way, you know, it's 360 degrees around in there. You have all that pressure on, you know, applying pressure at the top of the piston. A piston with a dome top will simulate more cylinder pressure onto the piston. It'll trick it into thinking it's a bigger bore. And the easiest way I can explain that to you guys is there's the straight line. That is the bore. Here's the dome. You flatten that dome out. Now it looks kind of like a squiggly line. But you flatten that dome out. Try to get them both where you guys can see them. Well, I guess I'll just do it like this. You know, set them right here in a flat surface. Look how much longer the wire is off from the radius. You just have that, you know, you just tricked that cylinder thinking it's got that much bore all the way around. And if you match the combustion chamber to that arch of the piston like the 4910s do, the 4910's got a really nice matched combustion chamber, especially if I do some combustion chamber work on them. You will have more applied pressure to the piston than you would with a flat top. Does that make sense, guys? Trying to, you know, I just showed you there, you know. Look how much you changed the bore size, or tricked it into thinking it's the bore size. That means you have the same amount of cylinder pressure applied to a smaller piston as you would if that was a bigger bored saw. In my theory, I don't, you know, I don't claim to be right on my stuff. This is just stuff that I've noticed over the years. So, but I have noticed, and that theory will be getting put to the test on the dyno pretty soon of my 7310s. Because that one, I cut a tapered domed piston in and matched the chamber. And that saw really does outpound my other 7310 build that put up 8.3 horse. So let's talk about some pistons then. Like I said, you got flat top, what I call a dome. Then you got pop-ups. Typically where pop-ups serve nice is on saws that you can't get in and cut chamber or bases, like clamshells. They typically work good for clamshells. Just how it is. But I'll tell you this: you come in and weld up a clamshell's combustion chamber versus the pop-up, and you will have more power out of the combustion chamber mod than you will that pop-up, because that pop-up disrupts your flow. But some saws like a pop-up better, some saws don't. You got skirts that are like this on some pistons. This is what I call a full skirt piston, pretty much. I guess technically that would be a full skirt, but you got your windowed, and then I should have a Dalmar one here. Right here. Here's a Dalmar one. This is what I call a convex one, and this feeds your transfers through here instead of via a window. Now, if you're absolutely looking for super strong piston, this design is super strong, but I feel it hinders. I feel you'll get more power out of, you know, one like this. And like on some 4910s, I got stuff stuck to my pointer, I'll come in here and flow these out a little better. They already have a nice arch here. I'll come in and take some of that out. They've got a nice arch on the piston. 4910 and 501s, just they're just a really well built saw. So that's something I wanted to talk about, was tricking your saw into thinking it was, you know, bigger bore, basically, with a dome piston, with a hemispherical top type piston. It's just how it is. You take something that's bent, you know, like this would be the top of your piston. There's more surface area here across that whole piston in every direction than there would be if it was flat, because you take the distance from point A to point B and then stretch it out flat, it's longer. It's just a physical fact. You know, you take, you know, just like that, you arch that piston. And this is over dramatized. I wanted to, you know, but I have seen in dirt bikes, I've seen two strokes have that much of a arch piston before. And there's more surface area on a piston shaped like that than there is with this one that's just flat. That's just how it is, guys. So that's some things. I didn't realize I blabbered on here for 28 minutes. I'm gonna have to call this a vid. You guys have a good one.